So hello everyone, what's up? So today we are going to solve minimum window substring problem. Okay, so I guess it is a point. Okay, I don't know. Okay, yeah, it is a part of blind 75 must do lead code. Okay, so given two substring s and t of length m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window. There is no such substring return an empty string. Okay, otherwise we should return the window, right? Okay, so what the question basically says is that, okay, I guess we have been provided with two strings, one is s and one is t, and we need to find the minimum windows, okay, in which we have all the letters of t. Okay, all the characters. Basically, if there are, let's say, two characters, let's say we have two a's, then does it means that, okay, we have to include 2 times a? Okay, so yeah, okay, including duplicates, yeah. Okay, and let's take this example. We have s is equal to a and t is equal to, so the minimum window will be a itself. Okay, and if we talk about this, in this case it is not possible because we have a and here we have only one a. Okay, so we have to. Okay, so I guess this is a follow-up which basically suggests us that, it is kind of, uh, order of n plus n solution, which basically means that, I don't know. Okay, I don't know. Maybe linear solution. Okay. Okay, so let's take this example, right? I hope, and let's try to make some observations. Okay. Okay, so if I understood the question properly, okay, if we take this sample case, right? Okay, so ABC. So how we can identify the minimum window? Okay, so the brute force, basically the the naive way which comes in my mind is that generating all the possible substring, okay, and check if all the letters of T are included in the substring. So what we can do is that we can create a map, right? Since it includes only the English letters, right? Okay. Okay, so it doesn't specify that it includes only English characters. So the characters can be anything, right? Okay, which basically means that the characters can be anything. Okay, acha, okay. So it basically means that uppercase and lowercase English letters. So what can I say is that I'll have total number of 26 lowercase letters, right? Plus 26 uppercase. So what I'll in order to check, right? Okay, so how we can check, right? So what we can do is that for the smaller string, which is the target string t, I will do one thing is that we can create use a map. Okay, and in the map we can keep track of the count. Okay, so that will be only you know uh, 42, right? Sorry, 52. So what I'll do is that, let's say this is the string, so I'll just in the map I'll just keep the count of number of A's, number of B's, and number of capital C's, right? And now what we can do is that we can generate all the possible substring in the S, and then we can, for each substring we will basically, for each substring we can, count the number of letters which are present, and if it is, greater than or equal to the number of corresponding numbers in the t, uh, in the map which is for t, then we can say that it is a valid substring window. And yeah, and we will generate all the possible substring window, and we will basically return the minimum one, right? Okay, so that is the brute of force, right? But that would mean generating all the possible window would cost us order of n square, and we are also checking for each window. For checking, it will take 52, so that would be order of 52 n square, which is, we can say that order of n square itself. Okay, but the constants are too high, right? Constants are 10 to the power 5, which basically suggests that we should think of another approach. Okay, okay, so what we can do is that maybe we can try to use two pointers, right? Okay, so since it is a window problem, right, we can, keep track of the window, and since the window size can be variable, right, so we can, maybe we can, try to use two pointers because we are trying to keep track of the window. Okay, so let's deal with this, right? Okay, so we have something like this. Okay, just, yeah. So let's say initially I was at this. Okay, so the first task which is already needed is that we will have a map which will store the count of A, which will have a count of B, and which will have a count of C, right? Okay, and now we'll have a pointer, let's call it I. Okay, so let's say this pointer initially is here, right? And okay, so if it is A, then it's fine. Now I'll have another pointer which is now, let's say, here. Okay, it's A. Okay, so I will have I will maintain a map. Maybe we can maintain a map in order to, keep track of the number of, values, right? So we can say in the current map which we have A one time, and now we have B one time, right? So we'll compare it with this map. Are both the maps, uh, uh, okay, not both the maps, we'll just compare that, if each letter in this map is less than, or count of the letters is less than or equal to the one in this map. If it is not, obviously I'll move on, so I'll just move my pointer, right? So I'll have something like, now J is now at O, right? Okay, maybe now we will have one more thing which is O, that will be J, right? Okay, then again I'll move forward, then I'll have B, right? So should I include B? Yes. Okay, so now I'll have one more thing, again it's not equal, so I'll have B. Okay, now again I'll compare, obviously we don't have C here, so again I'll move forward, again I'll have E. Okay, my bad, it should be 1, right? And similarly I'll have E, right? E, let's say E will be 1, and again I'll move my pointer. Now at this point, now I'll have CS1, right? Okay, so at this point when I again compare these two maps, so I'll say that this substring window is valid, right? Because the count of all the characters in this map, which is for the T substring, the count is less than or equal to the one in this, right? So which basically means that this is a possible substring window, which is ADOBEC, right? Yeah, so this is the first possible substring window. Okay, then okay, so we got the first possible substring window, right? but it is not necessary that this will be our answer, because there can be more of this, right? Okay, so what should be our next step right after this? Okay, maybe what we can do is that we'll say, okay, let's move J here. Okay, I don't know, should I move J forward? Okay, let's say I move J forward. Now I'll include one more, which basically means that now I'll have O one time, right? Okay, and this is also a valid answer, right? Okay, yeah. So what we can do is that, okay, so we know that if I is the starting, then the shortest, the smallest substring, which is starting with I, will be obviously ending at J, right? So now what we'll do is that we'll move I once, right? Okay, so I'll say my I now. Okay, instead of moving J, I'll say my I will be now at D, right? And from this, I'll just decrease the count of A, right? Okay, so now is this a valid window? Obviously, it is not. So again, I'll move J. Okay, so is this a valid window? Nope. Is this? Nah. Is this? Yes, it is a valid window. But the length of the string, which is a DOBECODE, it's not smaller than the previous one. So this can't be our answer. So again, what I'll do is that I'll move my I forward. Okay, if this is the answer, is it? Yes, it is the answer. So which basically means that this is our candidate. If it is our candidate, we'll again move my I forward. Now I'll check again if this is, okay, correct or not, right? Okay, so J should be here, my bad. Yeah. So if it is valid, if this substring is valid, right? If this substring is valid, uh, okay, if this substring is valid, okay, yeah. So if this is valid, which basically means that from I to J, this is one of the possible candidate, which can be our answer. Okay. Now from this, I'll move I again forward. Now this is also a valid substring, which is starting from I ending at J, and similarly we'll move forward. Okay, so yeah, so I guess in this way we basically are keeping two pointers, I and J. So we will move J till we get the first substring, which is equal to, which is a valid substring, right? The first valid substring window, and we will keep track of it in a maybe let's say some string, temporary string. And what will we do is that after that we will move I forward, right? And again check if it is valid. Okay, so if this window is valid, if the window is valid, then I will keep incrementing I. If the window is not valid, I'll keep incrementing J. Okay, so I guess in this way we will iterate till the end, and at each point we will be comparing the two maps, right, which shall take maximum of order of 32, sorry, 52. And since we are iterating I and J, so we will be iterating it total of m times, right? And we are also iterating through this t, right? So that would mean the time complexity would be order of m plus n, right? Yeah. So I guess it should be the approach. Okay, so let's try to code it up, right? Okay. Okay. So the first step is creating on-ordered map. So I will create on-ordered map that will, let's call it hmpt. Yeah. So I will iterate through t and I will increment t, right? Then I'll have another map. I'll basically have two map, right? This is okay, yeah, only one map, and one is, let's call it hmp current, right? Let's call it current. Okay, so now I'll have two pointers. Let's say the pointer is left and right. So left will equal to 0, right equals to 1, right? Okay, so now I'll have a while loop. So I'll run the pointers till some condition. Okay. Okay, so so I have a map, right? Okay, so it is pretty much done. Okay, so so initially my pointer I would be at the initial index, right? And my pointer j would be this index. Okay, so I will be incrementing j. Okay, if I will be incrementing j if, okay, so I can also say that right will be at 0 as well. So I will be incrementing r. Let's transform it. Let's call it left and let's call it right. So I will be incrementing r if the window is valid. It's not valid, right? Okay, and if the window is valid, then I will not increment r. So I'll have something like this: hmp current will be equal to left, if that's all right. Okay, my bad. It's my bad. Okay, s of 0 is the first character, right? I'll just increment it. Okay, so I'll say if it's valid. Okay, if the substring is valid, then I'll increment left. Sorry, okay, so if it is not valid, okay, so if it is valid, I'll increment left. Okay, it's just okay, yeah, so repeat, else I'll increment right. Okay, and before incrementing I'll have to do something, right? Okay, so if it is valid and I am incrementing it, okay, I'll have to keep track of result as well. So string result, it will be an empty string initially. Okay, okay, so how will I gonna check if the string is valid or not? So I'll just pass on both the maps, which is hmpt and hmp, okay, my bad, hmp current and hmp p. So I'll have one function, let's call this bool, it's valid. Let's call it substr, valid substring, and okay, my bad. Yeah, so here I'll have two things, which is unordered map, and let's call it char, right? Okay, my bad, it should be char, so let's call it hmp1, and we have another ordered map, let's call it t hmp2, or I can call it as target. Okay, yeah, so what I'll do is that I'll just iterate through all the target, right? So I'll have two things, right? Firstly, I'll have the element itself, the character itself, and then I'll have the count. So I'll say if whatever the HMP I'm comparing with, if HMP of char, which is basically the count, if it is less than count, then I'll just return false, otherwise it should return true. So yeah, okay, this is it, right? Okay, I am iterating through all the characters in the target, and I'm saying if the count in the map, in the current map, is less than the count in the target, then I'll return false, otherwise I'll return true. Okay, so if it is valid, then I'll be returning I'll incrementing L++, and I'll add okay, yeah, I don't need this continue because I'm using else statement. So I'll say okay, increment the left, and since we are incrementing the left, okay, which basically means that let's say R was here and left was here, so I basically want to shorten the window, right? So I know that from A the first minimum window will end at R, so I'll just, now I want for the minimum window which is starting with D, right? So I'll increment left, so I'll have to remove A, right? So I'll say from the map, which is HMP current, so I'll say before removing it will be S of L, I'll just subtract it, right? And yeah, and I'll just increment it, and okay, yeah, and otherwise, okay, if I am incrementing, if I'm doing R++, this basically means that what I'm doing is that I am incrementing R. Now my R will be at this new position. Let's say initially it was at A, now I am including B in my substring window, right? So I'll say HMP current of R will be incremented, right? Okay, and okay, so I should do this till my R is okay, so I should do this till my R is at end, right? So I'll say while my R is less than, I'll have something as n, so int n will be basically s dot size, right? Okay, so I'll do this till my R okay, just yeah, till it is less than n, right? So which is basically means that less than or equal to n minus 1. Okay, because in the last step my r will be increased to 1. Okay, n minus 1. Okay, so I can write it as r is less than equals to n, right? Okay, so it will be not r, it will be s of r, right? Okay. Okay, and I'll have one more condition, and left is less than r. Okay, okay, so let's say if I have something like my left is here and my right is here, I will move my left here and my right here, right? So my left and right are at the same position. Okay, yeah, I cannot move my left forward, right? So yeah, okay, so initially, so my left and right are at the same position, right? That would mean, okay, so my left and right, yeah, I'll say left is less than or equal to r. Okay, I'll have to take care of some edge cases, I see. Okay, so I guess this is good enough, right? And now only I need to check one thing is that okay, so if it is a valid substring, okay, so it basically means that it is a valid substring, right? And if it is a valid substring, so it is a valid substring, right? Instead of storing string, right, which can be easily manipulated, so what I'll say is that int I equals to 0 and j equals to 0. So I need to store the minimum window, right? And I need to store the max size as well. So max mean size, initially mean size will be int max, just trying to make it efficient, right? Okay, so I have three things. I have ij min size, which basically stores the minimum size of the valid substring which we found, right? So I'll say if the size, which is current size, so the current size will be whatever my right is, right minus left plus 1, right? Let's say if I'm standing at this index, so my right would be 0 1 2 3 4. 4 would be my right and 2 would be my left, so the string length would be 4 minus 2 plus 1, right? Yeah, so this is my size. If current size is greater than sorry, it's smaller than min size, then I'll just do something. I'll do I is equal to left, and j will be equal to right, and my min size would be equal to current size. That's it, right? So this is the main logic, I guess. And okay, so yeah, so this should work now. But here we have an edge case, right? So let's think about some edge cases, right? So the first thing that comes to my mind is that what if you know, let's say that we are somehow, my left is here and my right is here, and let's say that including O, if I include O, then BECO is one of the valid substring, right? So if this is the case, which basically means that I am at R, so BEC is not a valid substring, and I am saying that when I increment R plus plus, so when I am doing R plus plus, so this is a valid substring, right? Okay, so this is a valid substring. So my R is equals to n, right? Less than n, and now it will move here and it will check if this is valid or not. Okay, so if this is valid, so it will include BECO, right? If it is not valid, then I will increment R plus plus and it will come out of the loop. Okay, yeah, that's great. And maybe we can have a case, right? So when we have only one element, so let's say my S will have something like A, B, C, let's say, and again let's say we have A as well, and I'll have something like T will have something, maybe a single element, maybe A. Okay, so I want to check, right? So initially my left will be here and my right will be also here. So I'll check if left, okay, so I'll have to check if, you know, it is valid or not, right? So it should return A in that case, right? So the expected output is A, right? Okay, so in this case, since my left is equal to right, and I'll check if it is valid or not. Yes, it is valid. If it is valid, then what I'll do, I'll increment my left. So my right will be here and my left will be here. Okay, in the next case, what I will do is that in the next case, what I'll do is that now since it was valid, so I got one answer. Now in the next case, now my right is behind left, right? So in the next case, I'll check, okay, if this is valid or not. Right, so in the next substring, what I'll check is that if this is valid or not. It basically means that, okay, in the next substring, I'll obviously, my map will contain nothing, which basically means that this will be invalid. So I'll increment my right, so I'll have B in my right. So I'll check if it is valid. Nope, it is not valid. So I'll increment my R again. Okay, so it is valid, so B is the possible answer. Now I will increment my left. I'll check if it is, yeah, So it should work, and I guess it is not needed. Okay, and obviously left must be less than n, and yeah, and obviously after this I get my I get my j. So I'll just say result. Okay, so if I didn't get anything, right? Okay, so I'll say if min size equal to int max, then I should return empty string s. Okay, otherwise I should return s dot sub str starting with I and ending with min size. So yeah, so let's run the code. Any errors? That's it. Weird. Okay, okay, my bad. It should be cat 2 int, right? So my bad. How can I make this kind of mistake? It should be again, yeah. Okay, okay, it's not working. It should work, right? Error expected. First one is character, second one is count, right? I don't know, it should be correct, right? Okay, target, I don't know, let's call it x. Okay, my bad, it is ch. Yeah, my bad, because char is reserved. It's keyboard, right? Okay, and one more thing is that hmp t not hmtt. Yeah, okay, my bad, so many compilation errors. Okay, let's try to submit it. Let's hope it will. Yes, finally it is done. It is showing slow. I don't know, it should be fast enough, right? Because it should be fast enough. I don't know why it is not fast, but yeah. Okay, that's great. Okay, so how can we improve the efficiency, right? Maybe we can improve it more. Yeah, I guess what we can do is that, when we are making the first check, right? If we somehow figure out the first optimal window, sorry, not optimal, the first valid window, let's say this is the first valid window, right? After that, we don't need to check the whole mapping, right? We can say that, okay, so this is the first window. Then in the next step, if I am deleting, I am moving a pointer here and I am talking about this window, I should just check that after removing a, if it is valid or not, right? Which basically means that, okay, since it is checking if it is valid, right? And it is removing, then again it is going into this one. So instead of that, I can make a check here, right? I'll just say that, okay, it was removed. Now just check if it is valid or not, right? Yeah, it should be the case. That can make it, a bit efficient. Yeah, so but yeah, I guess it is, this solution is fine enough. Okay, yeah, this solution is fine enough, I guess. So maybe, yeah. Okay, so let's meet on the next question. Till then, enjoy and keep solving.